Share my screen now.
Can we record it?
I think it is recording, yep.
Yay.
So those folks who are online probably didn't hear the introduction, so apologize for that, but I'm John Altsholt. I'm going to go through some of my background here. We're here in Geotech, Colorado offices, and this is a UAS Colorado kind of co-sponsored event. So I'm going to go through a little bit of my background first, and then we're going to look at some processes, photogrammetry, and look at some actual data. So again, my name is John. I'm a landscape architect, registered in Colorado and California. I really specialize in environmental restoration work and also outdoor recreation. Now, the other side of my career has always focused on 3D modeling, data visualization. That's where the drone stuff comes in, and you'll see that in a bit here. I am, of course, an FAA remote pilot, part 107. And then, as mentioned, I'm also an author. I have a book out. I'll have it up at the end here and do things like this as well. So on the landscape architecture side, again, stream restoration, environmental restoration, kind of the not the most typical landscape architecture stuff that people typically think of. Parks and commercial buildings, things like that, isn't really where my profession has gone. And that inevitably led to transportation projects. So all over the world, especially in Colorado, we tend to build our highways right on or right next to rivers. So as a result, I've worked on a ton of transportation projects, and that has come into some really cool work for drones. So my other specialization, as I started to mention, visualization, technology, 3D modeling, 3D rendering, really integrating this throughout the design process, not just at the end for pretty images. And that led to integrating drones. Where it first started about 5 or 6 years ago is we wanted more context for our 3D models. So basically when we were doing 3D models of projects, we wanted to be able to go somewhere, use a drone, get a 3D model of the existing terrain, existing structures, and model into that. So I don't know, are you guys able to see the screen all right, or should we shut some lights off? Okay.
Maybe that's
We're able to?
Okay,
Okay, perfect. So
oh, wow, that's
this
good.
project, everything that's the bright colors, so the bridge and the pathway, that's a 3D model. That's proposed, it doesn't exist. The rest of it is what's called photogrammetry, and we'll go over what that means. But it's a 3D model of the existing site conditions. So I was able to go out in an hour or two, collect drone images, drone data, come back, process it. And then as a team, we have a 3D model of the entire site that we can design into in 3 dimensions. So that's where it really started. We just want better context for our 3D models. But it's led to all sorts of other stuff. So this is that same project, and these are the final visualizations. So you can kind of see the white grid is what's from the drone, but then we can apply the textures from the drone, and we get this really cool 3D model that we can use for public outreach, for design, for fundraising, all sorts of uses. So it's led me to a lot of different places. So whenever I present on drones, usually the first question I get is, why do we use drones in our practice? And it's different for every project, but overall, typically we use it when we can reduce cost, we can expedite the project schedule, we can minimize the footprint on sensitive habitats. I do a lot of river stuff, a lot of environmental restoration. So if we're able to collect data without trampling all over stuff, that's great. And in a lot of cases with drones or UAVs, UASs, we can increase the accuracy of the data we can collect. We can increase the awareness of the context. We can increase the types of data we have available to us. And we can increase the use of that collected data. So if we're being able to collect more kinds of data, that means more people on the team can use it for different uses. And I'll show you a couple examples of that. And so then the second question is always, well, okay, that's why, but how do you use the drones? And I always like to separate it into 3 different categories. The first or simplest is just collecting photos and videos. The next is collecting 3D data. And then the final one is actually working with that 3D data. And if you look at drone users and those same groups, there's lots of people collecting photos and videos. That's the simplest or lowest barrier to entry. The next step up is collecting that 3D data, and you have less people, but still a lot. And then that upper top tier is where you're collecting the data, but you're also working with it. So you're doing analysis, you're doing the 3D modeling, and there's a number of people, but it gets to a smaller pool. Today, we're mainly going to be looking at collecting 3D data. So with that, we're going to go right into it. And there's a couple different methods. The 2 main ones are photogrammetry and LiDAR. They both have their benefits. They both have their downfalls. Today, we're going to talk about photogrammetry. How many people in here have heard of photogrammetry? Cool, quite a few of you. So some of this is going to be review or repetitive for you, but photogrammetry has been around for decades. Essentially, it uses a series of overlapping photos, so taken at different points in space. And if you know the points where those photos were taken, and you know some of the camera parameters, so the focal length, the sensor size, things like that, then you can use algorithms, and there's software like Pix4D or Metashape. There's a few different ones out there. And it'll use the software to actually create a 3D model. So from those overlapping photos and from the math, it'll detect the actual real position of points within those photos. So it creates a 3D model, a point cloud and a mesh, and the accuracy really relies heavily on how much overlap you have with the photos, the angle of the flight pattern, and we'll look at these things, how far you are from the subject, and finally ground control points. So ground control points are points within the photos that are marked that you can see, that you know the actual real coordinates of, and that's really important. So what can we get out of photogrammetry? First is orthorectified high-resolution imagery. This is basically like a map. So it's been orthorectified, means it's been corrected for the curvature of the Earth, curvature of the geometry, and so you can bring this into GIS, Civil 3D, you can take measurements off it, and it's really high resolution depending on the drone you're using and how far you're flying. When I say really high resolution, with a pretty cheap drone, $1,500 or so, if you're flying from 200 feet up, you'll be at like 0.5, 0.6 inches. So that means if you zoom in on this, every pixel is 0.5 or 0.6 inches in real life. And you can get even closer and get more accurate or higher resolution than that too. The next thing we can get out of this, and this is the same view we're looking at if I switch back and forth, is a digital elevation model. So how many people work with GIS software? A few of you. So GIS software, you're probably very familiar with digital elevation models. It's a raster image, so just like the aerial image here, it has pixels. But for the elevation model, every one of those pixels has an elevation assigned to it. And so that's why it looks like a hillshade here. And so we have basically a 3D data set now. And from that, we can even extract contours. So we can do these including everything, so trees, vegetation, you know, stuff we probably don't want, or we can filter those things out to get to closer to a bare earth. This is one of the things where there are some benefits to LiDAR over photogrammetry, depending on your specific site. Photogrammetry can be a little bit tougher to get good data through really thick vegetation. But again, we get topographic contours out of this. And then we go to kind of the 3D side, because even though that had elevation, we're really looking at all of it in 2D. So the basis for the 3D data set, and we'll look at a few of these, is the 3D point cloud. How many folks work with point clouds? Okay, so maybe a third of you. So a point cloud for photogrammetry, basically these are tens or hundreds of millions of points. If you look at the zoom in, you can actually start to see the points in there. And every single one of those points has 6 values, an X, a Y, and a Z, which is defining where in space that lies. And these can be tied to projected coordinate systems, so they can tie right into surveys and other data sets. And then it also has an RGB, a red, green, blue. So every one of those little dots, those points, is one color. But when you start to look at the whole picture, you can see it creates the entire data set together. And from the point cloud, we can create, here's just another close-up of the point cloud. And from that, we can create a 3D textured mesh. So this is basically a solid surface. And you might be wondering, well, why a 3D point cloud? Why a 3D mesh? It depends how you're going to use the data. So a lot of my projects, the 3D point cloud might be the deliverable. Other ones, especially if I'm doing 3D modeling of proposed features into it, this is what I want, because I can take the mesh into software like SketchUp, 3ds Max, other things, and I can do visualization, 3D modeling with a mesh, which is typically what's used for modeling. Point clouds are a lot of times used for more analysis. The other thing that gets overlooked that I think is really powerful is you've collected all this data, you've processed it all. You basically have a virtual 3D site inventory. So this is a screenshot from Pix4D, and you can do this with lots of different softwares depending on which one you're using to process. But what I like to do with a lot of my bigger projects is I'll give them the entire data set and help set them up on a Pix4D license. So then that entire project team, no matter if it's an engineer across the world working on it at 2 in the morning, or it's me working on it here, we can hop in, we can view the entire site in 3D, we can click on points, We can look at the full resolution photos. It's basically a site inventory, virtual. No matter what time it is or where we are, we have access to that. So what does this process look like? Because I basically threw a bunch of stuff at you guys and said, look at the cool stuff we can make, but how do we do it? So this is it, kind of outline. So first we're in the office, we're doing all the pre-flight planning. So we're looking at weather, we're looking at where we're going to get ground control points, where we're going to fly from, how many batteries we're going to need, how many flights it'll take. So that's a really big part of it. And then we have the drone flights, then we're back in the office. So we do the processing, we add the ground control point data, we get to our point cloud and 3D mesh. Depending on what we're doing for the process, sometimes we're doing SketchUp modeling, sometimes we're doing visualization, sometimes rockfall simulation, sometimes we're just giving off the 3D site inventory or some of those deliverables. The really important part that I like to point out on this, the actual drone flights is a really small part. If you don't plan properly beforehand and process properly afterwards, the flights don't matter. So flight planning, again, it's key. You're looking at flight areas, battery times, operator areas, making sure you're following all the FAA regulations. For me, a lot of times, especially because a lot of times I'm doing stuff in other states or that I can't go visit the site in person beforehand, starts in Google Earth. So in Google Earth, I can start to take measurements, I can use Street View, and I can start to figure out how many flights it'll take, how many days it'll take. Are there big power lines? Are there things I need to be aware of? I can check the FAA airspace online as well. And then every project has some unique considerations. So I said I do a lot of transportation. So sometimes it's traffic control. Sometimes it's closing down a lane of I-70 and standing on the highway flying while people yell at me about the traffic. Not that that's ever happened.
Just remember, you're number one.
Weather planning. So super important, and you can't control it, but you can control your planning as much as possible. So plan backup days, plan when you're going to need to check the weather leading up to it. I flew a site in Silverthorne last week, and the night before I was up working late at like 2 in the morning. It said it was going to be gusting like 50 miles an hour. Well, great. Went up anyways because it was the only day that worked. There was no wind at all, but I had a backup day a week later planned in there just in case. And then finally, ground control points. So ground control points, again, it's points in the project area. They have to be visible. You can paint stuff if you want. It's not as accurate. I'll show you some other methods as well. But they have to be visible in the photos, and you have to know the actual coordinates of them. So when we talk about the accuracy of our photogrammetry projects, there's two categories. There's relative accuracy. So if I'm taking measurements from this point to this point within my model, how does that match up in real life? And then there's absolute accuracy. So if I'm trying to tie this into State Plane, Colorado, North Central, or North, US feet, how close is that point in my model to the actual coordinate in real life? So that's absolute accuracy. Ground control points will increase both, but they're absolutely necessary for any absolute accuracy. Depending on the project, you can still get pretty good relative accuracy within the model without ground control if you need to. And then the flight planning, so flight options. So how much overlap between each photo? Remember, photogrammetry is all about overlapping photos. How far are we from the subject? Depending on what camera model you're using, the distance to your subject is going to define the resolution, how big those pixels are. And then what type of flight pattern, which I basically group flight patterns into two categories. The first is horizontal nadir grid. Does anyone know what nadir means? Straight down. Yep, looking straight down. So it's a horizontal grid. This is our flight path, the white lines, and you can automate this. So you can program it in the field or beforehand. And basically you go out, you press start, the drone takes off for you, points the camera down for you, takes the pictures for you, comes back and lands for you. These are scarier than the manual flights to me because I like to have control. Now you can take over at any time, but it's automated. This works really, really well for rolling or pretty simple terrains. You're staying at a consistent height. It does not work well for vertical forms, complex forms, so buildings, overhangs, rock faces, things like that. So if we have a vertical form, we use what I call an oblique grid. Oblique simply means the camera, rather than pointing straight down, it's at an angle. So we basically fly around the subject Typically, it requires more overlap. And the way I like to explain it is, imagine that this fist is the rock face, and we have our horizontal grid that we had before. Basically, we're turning our grid on its side, and we're trying to wrap around the rock face. So this is a 3D model. Every one of these little green dots, and we'll look at one of these, is where a photo was taken. So basically, we're going up to an altitude, going across taking photos, going up, across taking photos, and so it's a vertical grid like that. But you can see in the plan view, each of those red dots in the upper right is a photo as well. You can see how we're curving around. So this is a valley on the lower right, so we're curving around to get pictures of that rock face. We're wanting to basically keep that camera as normal or as perpendicular to the rock face as we can. So down near the bottom, we're taking pictures that are close to Nadir or at a little bit of an angle to get the roadway, get the bottom of the rock face. And as we move up, we're at more of a almost straight out camera angle. So then we've done all the planning, and then we go out and we fly. There's always things you don't think of. So again, build in time whenever you can. These are just some pictures from various projects. These two are both from I-70. You can see sometimes you have very limited flight areas. For I-70, we basically closed down one lane, and we could fly over that lane, but we couldn't fly out over the traffic. We also need to stay fairly close to the rock face for the resolution we needed anyways. There's always weather to deal with. Sometimes you wind up with your drone in a porta potty waiting for the rain to die out. All kinds of fun stuff. And then again, I just want to hit on ground control points one more time. Required for that absolute accuracy. And so these work a lot better for paint, mainly because you can zoom in. Again, we're looking usually at like half an inch or so. So we can zoom right in. And if you have a paint mark, it's tough to tell what's the center. With a checkerboard like this, it's really easy to tell, okay, that's the center point. That's the point I recorded and that I know the coordinates of. And so just to, again, hit on ground control points, this is all one data set. The left side, the blue dots are where the drone thinks it was from its onboard GPS. The middle part of it is from the ground control point collection. You can see it dropped it way down and shifted them a bit. And so then we have the final on the right. So again, the relative accuracy, so measuring points within the model, will be pretty accurate, even if you don't use ground control points in most situations. The absolute accuracy, horizontal and vertical, will definitely shift when you add in that ground control point. So it's really important. And then back to the office. So you come to the office, you download all the photos. The photos have little geotags in them. So basically they have geolocation data in the photos. And so this was a project on I-70. This was for about 2 miles of roadway. And the thing I want to point out is the file size and file organization is really key. So just the photos was about 175 gigs. That was about 23 miles of flights in the air, 37 flights, about 10 hours, 19,000 photos. So files get big. So organization, knowing where the files are, having a process of when you archive them to a backup drive can really be a time saver. Process it with photogrammetry software. The ones I show you guys today are all done with Pix4D. So this, you'll see is a horizontal Nadir grid. You can see all the camera points are pretty much level with the ground, looking straight down. On the right side is the same project, but looking at a map view. Those blue crosses, by the way, are the ground control points. So you do the initial processing, and then you add in that data. So basically, you click on the point in the photos, the center of the checkerboard, and you can input the known coordinates for those points, and then you just tell it to reprocess. It's much shorter than the initial one, and basically it corrects or rectifies that whole data set. And so these are kind of showing those steps. So initial point cloud, this is all one data set. So you can see there's some holes in it. Final point cloud basically fills in all the holes. And then we have a solid mesh over here on this side. And we'll look at some actual data sets so you can see the detail on them as well. Here's another example. So again, initial processing, final point cloud, and then on the far right, the 3D mesh. The little green and blue arrows on the roadway are ground control points. For this project, we were not able to survey up on the rock face. So we added some manual tie points on it. Basically, that's just selecting in the photos, giving the software some more info that yes, in fact, this is the same point in these 12 photos or however many you mark, and it'll just tighten up that data set some. So then after we get the 3D stuff, we can get kind of the extras, as I call them. And that's the orthorectified aerial, the DEM, and the contours. So here's a DEM. You can see the elevation, you can see the creek channel, you can see the road along the bottom. This was a photogrammetry data set, I think 3 flights with a small quadcopter, so pretty quick, under an hour or so to collect it. And now I want to show you guys 2 different use cases. Looks like that photo is not loading, so we'll just go to the first use case. So basically both these use cases, I'm going to talk you through my approach for them and then show you the actual data. So the first one is a state park here in Colorado, working on trail planning and park planning for it. So there is a specific area we know we want to site a visitor center and some trails. Pretty out in the middle of nowhere, so the relative accuracy was fairly important, but this was really just for conceptual planning too. So we wanted to be able to get an idea of the different elevations, if we could get access in, where we could start siting building, trails like that. So the main things we wanted out of it, that orthorectified imagery was really important. Elevation data, at least for a conceptual level, and the contours, ideally without the vegetation. You can see there's a pretty good amount of veg here. And then a 3D mesh, because we're going to do 3D modeling into this. So with that in mind, then we look at, okay, how are we going to collect it? The terrain is rolling. There aren't any major terrain issues. And so from that, we're going to do a horizontal Nadir grid flight pattern. Now there is a decent amount of edge, but it's spread out too. We can see through it decently. So here's what we did. We flew one Nadir grid, looking straight down, automated. And then we did a second grid. We rotated basically the whole flight pattern 90 degrees. And rather than nadir, we tilted the camera about 25 or 30 degrees. So if we look on the left, you can basically see the flat pieces. Those are just thumbnails of the nadir looking straight down images. And then you can see angled ones. And what that gives us is it gives us more info, more data about under the trees, because we're getting photos that capture some images and pixels kind of under and around the trees. So 2 flights total. And so then the vegetation, we can remove it multiple ways. And I'm going to show you the data. You can do it in something like Pix4D Mapper or GIS software, and then we can also do it either through manipulating the point cloud, so filtering out trees, or we can do it through DEM manipulation. So basically we can, through GIS or Pix4D or other methods, tell it to ignore certain extreme changes. So essentially it's kind of generalizing the whole DEM and the contours. And here's what it looks like some, and I'll bring you into the actual data set. This is orthorectified aerial. So here's the original DEM. You can see it includes all the trees. You know, not great for doing elevation planning. I mean, we could take points and understand the overall grade from one point to the other, but we're going to have the contours are going to include all the trees. You can see all the contours are going up the trees. So that's not what we want contour-wise. So I did that method I talked about, basically generalizing the DEM. And so here's our new DEM. And so you can see there's still some nubs from some of the bigger trunks of trees, things like that. But essentially we have a really nice clean DEM, especially for conceptual level planning now. And from that, here's our 1 foot contours. So 2 quick flights, a little bit of processing, a little bit of cleanup, and we're at this, which is a pretty incredible place to be at for conceptual planning. So with that, let's go ahead and take a look at some of the data. So first I'm going to show you Pix4D. So this is the software that we bring all the photos into and we do the photogrammetry processing. This is that plan view that you saw a screenshot of. And so you can see the aerial in the back. That's just from like Google Earth or Mapbox. That's just satellite imagery. So then we can go into our 3D array cloud, and everything's already processed on this. And I'm going to show you the cameras first. So we're in 3D now. And you can see the cameras. It generally follows the terrain. And this one, remember, this is where we did 2 grids. So 1 grid looking straight down nadir, and then a 2nd grid, rotate 90 degrees and at an angle. If we zoom in, we can even see the thumbnails of the photos. And you can see the angled ones and the flat ones. So after you do your first step of processing, this is what it looks like. Initial point cloud, not a whole lot there. And then we do our full processing to get the full point cloud. And here's our full point cloud. So even though this looks like a picture from here, if we zoom in, you can start to see the individual points. And you can see, even though there's trees, we got pretty good data in and around those trees by doing that second grid at an oblique angle. The other thing I want to show you guys here, remember I mentioned you can basically use this as a 3D site inventory. So if I click on any point here, it's going to bring up, we'll see if it'll load. The laptop, it might not. But when you click any point in the sidebar, there we go, it'll bring up every single photo that that point appears in. And I'm going to zoom them out. So this is like a water tank. And I can just tap my spacebar, and this is the full resolution photo that it's linking to. So I can investigate anything I want on site once this is processed. And you can see this point showed up in 110 different images. So that's the 3D site inventory part of it. Now from that, this isn't going to look too much different, especially on the projection, but I can also get a triangle mesh. So the mesh is solid. So if I zoom in on this, we'll see some of the pixelation of the image, but we can see it's a solid mesh. It includes the trees and everything because I haven't filtered any of that out. But this I can take into SketchUp, which is a 3D modeling program. And then, so this one in particular, we're looking at siting a visitor center up on this hill, but there's challenging terrain to actually get access up there for road and everything. So in SketchUp, I have a one-to-one perfect model of this that I can start doing all my conceptual planning of where can the road go, what will the grades be, where can we site the building. And it's a really, really powerful tool for that. The other piece, which I guess I don't have it pulled up, but I can pull it up if people have questions. So I have it in GIS as well. Can use QGIS, ArcMap, it really doesn't matter. But you can create like the color hillshade like this. So you can start creating plan view maps, all sorts of stuff in QGIS. You can do additional analysis if you want, view shed analysis, slope analysis, all sorts of stuff in any GIS program. Questions on any of that before I go to the more specialized use case? And let me plug my laptop in real quick.
What file format is your mesh in that you can import into SketchUp?
So I use OBJ for that. Okay. There's a few different ways. OBJ is the best for SketchUp. FBXs are a really nice 3D mesh for going into some other visualization softwares. They seem to retain some of the detail a bit better in certain ways. All right. There we go. All right, so then the other use case, which this is pretty specialized, but I do quite a bit of it with geotechnical engineers. Do you have any geotech engineers in here? Nice. One. And so he works with the company Yay, who I worked on this project with. So geotechnical engineers are basically like combining a geologist and structural civil engineer. It's a really interesting profession. How many people heard of the Boulder Canyon rockfall that closed the roadway? So after that, when they were cleaning it up, basically the CDOT and the Yay geotech engineers were looking at what was left on the rock and said, okay, there's some areas that we might be concerned about. So then basically have me go out, fly it, collect a very, very high resolution, very detailed 3D model. They can take that point cloud and do all sorts of analysis on it. So point cloud is the main deliverable for this one. The relative accuracy is important. Absolute accuracy didn't matter as much. And we were on kind of a short time frame because, again, it was after a rockfall. They want to figure out what the stability is. They want to do assessment. So we didn't collect ground control for this one. So this is a vertical rock face. That Nadir automated grid will not work. We'll get trash data if we do that. So again, I'm going to take that grid, turn it on its side, and curve it around our rock face. So left side is the plan view, bunch of dots stacked on top of each other. The right side is our 3D view. You can see all the green dots. And it's a little tough to see, but if you look closely, you can see like I had 2 or 3 rows of dots at this bottom row. That's because I go up to a height and I want to be normal or perpendicular to the face, but we have the road face, we have the cliff face, and we kind of have this in between. So basically a row of photos looking at the road, tilt up a little bit to get overlap, a row of photos to capture more of that in between, and then another row of photos where we start to get more perpendicular to the rock face. And then we go up and across and up and across and all the way up. So again, manual oblique flight grid. I'm manually flying, I'm manually capturing the photos. We want to be fairly close to the subject. The analysis that the geotechs do on this, basically the more resolution, the more detail we can get, the better. These rock faces have all sorts of strikes and dips and different features and formations through them. We want to try to capture that so that they can do the analysis. So typically flying between 30 and 80 feet away from the subject. The last project, we were 300 feet up, by the way, looking down, so 300 feet to the subject.
How sensitive is it to maintaining a fixed distance on your subject?
Mixed bag. So as much as possible, you want to stay fairly consistent, but the softwares are advancing so much, they're being made to combine different data sets, so even iPhone or DSLR photos with aerial photos. If you're getting enough good data, good photos that the software can pick out the points to tie together, and especially if you're combining it with some ground control or even like RTK GPS on any of the units, so you get really good positioning on where the drone or camera is, you can vary that more. So you're wanting to stay fairly consistent, but you don't have to hold to it exactly, if that makes sense. So when I say for these Geotech rockfall ones, we want to get extremely high detail, that's not a photo, that's a 3D mesh. And this is a point cloud. So if you look out here, you can see little points of the barrier. So that's what I mean by extremely high detail. We're looking at like 0.3 inches or less from one point to the next. So here's another one. This is the 3D mesh. Same project. You can even see the barrier, which we don't really care about too much in here. Couple handsome guys standing there flying drones. And we'll see if this video plays. This is a fly through of the 3D mesh, and I'll pull the data set up here so we can actually look at it. But this shows off kind of the level of detail that we're going for these projects.
What drone did you use for that?
Phantom 4 Pro, so $1,500 drone.
How did you look under the? How did you get the cameras look under that?
So I'll show you the cameras, but basically the slope falls off. You can see it there. So I'm flying kind of outside the roadway. And so I'm basically just down at the level where it's capturing under there. I probably should have gotten actually a little bit lower, but it worked for what they needed. So let's take a look at the software. All right, so here's our plan view. Doesn't look like much because they're all stacked on top of each other, right? Like if I zoom in, we can start to see the individual dots, but that doesn't mean a whole lot. Now, if we look at the gray cloud, turn off some of this stuff. All right, so here's the cameras. So you can see, like over here, we're low enough, and this is where I say I wish I would have done one more kind of half line here. But we're low enough down, and we're looking that, think of the field of view of the camera, it's capturing pieces of the underside of all those overhangs. If we look from the side here, you can kind of see, it's a little confusing, but I'll point it out. So here's our close to nadir looking at the roadways, and then another set looking up a little more, and then another set looking up a little more. And then as we go up, we start to get more.
John, is this not autonomous?
This is all manual.
This is all manual.
Yep, so manually sticking, flying, and manually clicking the shutter. No carpal tunnel yet.
Yeah.
You don't set it to just like the shutter if you say.
So it's quicker than that I'm needing to take the photos. Yep. There are some softwares coming out that are getting closer to being able to do this automated, but it's not quite there yet. There's probably 3 or 4 that I've seen that I think are getting very close. One of them can actually do it very well, but only if you have a decent quality mesh of the existing terrain. So if you have something that's not this level of detail, it can, but still higher than what like Google Earth or the shuttle mission data sets are, it can create a flight path based on that where it follows the terrain essentially. So yes and no. Like a KMZ from Google Earth, the resolution is going to be so low that it's probably going to fly into a cliff, right? Because it's generalizing it. The company that's making this one, I forget their name. They're out of Switzerland, I think. No, it's not Wingtra. No, and Wingtra is an amazing fixed wing drone, but for like 200 feet away plus. Can't really be closer. No, it's made for quads, and basically where they are, it's very common. The entire country has a fairly high resolution data set. So they have a good data set that they can import and say, okay, make a route off of this. We have, depending on what county you're in, you might just be SRTM, which I'm trying to remember the resolution, but I want to say it's like 50 meters or something. So basically, if you think of the Earth, it's split into 50-meter chunks. And so every 50 meter by 50 meter, you average the elevation, it thinks that's the elevation for that entire area. So something where you need to be within 30 to 80 feet, you're going to either be way too far away or you're going to fly into the side of the cliff. So they're getting a lot closer, I think, especially with drones that have like laser rangefinders on them and things like that, but they're not quite there yet to automate it. So I'll turn the cameras off. This is our initial point cloud. Here is our final point cloud. So if we zoom in here, you got to zoom in pretty far to start seeing the points. And you were asking about the overhang. So we got most of them pretty well. Here, I'll show you where I wish I did one more flight a little lower. You can see we're starting to get a hole there. Yeah. But if you look at basically the boundaries, we're basically getting all the boundaries of it. So when we, actually let me zoom in on that part. When we, either in this software or in the Geotech software, create the 3D mesh from the point cloud, you can see it has enough info to still fill it in really well. And I'll turn our point clouds off. Here's our 3D mesh. So we could take this into SketchUp or something else, and you can see the level of detail on it, both in terms of color, but also kind of the more important, the geometry, right? The accuracy and resolution of that data set.
How long does it take you to get that really tight file fixed?
To process it?
Yes.
Can check. Processed on my desktop, which to be fair does have a 3090 video card, 128 gigs of RAM, and an i10. So it's a powerful computer. But this is about 780 photos, if I remember right. Yeah, 760 photos. So it's not a huge data set. It is getting a lot of points out of it, as you can see. So a little under 2 hours to densify the point cloud. Some of the larger projects that I've processed with Pix4D are more in the like 3,500 photo range. But typically, depends on the project. A lot of times the points aren't as dense as this. So, for me, it's all about choosing you look at how you're going to use the data in the end, and that's how you choose what hardware you use to collect it and the process or method to collect that. Yeah.
Are you seeing a correlation between photo density and point density, or is it just about where you take the photos from?
It's a good question. I don't know for sure. I'd have to think it has to do with mainly that GSD, the ground sampling distance, which is really just a calculation of the sensor size and how close you are to the subject. So, because the closer you are to the subject, the more points you'll have per square meter, square foot, whatever. So it'll be, no matter the number of photos, be higher the closer you get. Question? Okay. So with that, one little pitch for myself. I recently co-authored a book, Drone Technology, someone in here has it, in architecture, engineering, construction. It is on Amazon. And so that's a good resource. And my email there at the bottom, I do have cards and some stickers and stuff I can put up out here for folks, but otherwise happy to answer questions.
Does CDOT measure the amount of rockfall in these events to understand how much and weight and volume?
He can probably answer that better than me. So we flew this.
I'm on the construction side, I'm on the design side. Most of the shoots and stuff in the state are identified, and it just depends on stability.
Right, but I'm assuming you're trying to get some understanding of the scope of it.
Yeah, but a lot of times what the designers are looking for is what the slip planes are, how the rock sits, and then whether it's stable or whether we're looking at the shelf is going to slide, so we have to
Okay.
Yep, and this one we flew it after the cleanup. So I've never had to fly one like with the rockfall on the road. It's always been like this after the cleanup, or for a construction project, we want to figure out what are the trouble areas, how do we mitigate them before starting construction. Yes.
Let's do the cover on your book. Do you really use a Nadir Pro for that stuff?
So almost everything I showed you today was with a Phantom 4 Pro. I do use a Mavic 2 Pro as a backup because it's so portable. What's that?
Not the Pro itself.
No, it's the Mavic 2 Pro, so not that one. The Mavic 2 Pro is almost identical in all respects to the Phantom 4 Pro. The only difference is it has a rolling shutter. So for photogrammetry, you can definitely use, and the software can correct for it, but it's not the first choice. Yeah.
Instead of taking stills, have you ever just tried to extract them from the video reel?
You can do it. The resolution's lower, so you get lower points overall. Yeah.
So were you using the camera that came with the Phantom 4?
Yep, stock camera. Not the RTK. Sorry.
20 megapixel.
Yep, 20 megapixel. Both the Mavic 2 Pro and the Phantom 4 Pro. The nice thing is it's a 1-inch sensor, if I remember right. So the quality of the pixels you're getting are pretty good with that camera.
Have you played with the Skydio mapping feature at all?
I haven't. The thing that worries me with the Skydio is the sensor's tiny. So the pixels are kind of cruddy quality. They have some amazing software for moving around objects and detecting them, but the sensor is so tiny, the pixels just are not going to be as good. What's
I
that?
didn't realize it was
Yeah, I keep waiting for them to come out with an option for a better camera, but they haven't. So
Could you jerry rig it with a different camera?
I'm sure you could.
I know that's a technical term.
Sure.
Jerry rig.
Or just creating meshes and shooting for photorealistic
Sure.
renderings. Well, what software would be best for that? I know there's so many like Pix4D offerings.
Sure. So like this one that's on the cover, and I showed you guys a screenshot of it earlier. So that's a mesh from Pix4D. I brought into SketchUp. SketchUp, I modeled the bridge and path, and then I brought into a software called Lumion, Lumion, and it's basically a rendering engine. So you can bring in SketchUp models or other models, and you can add in trees, you can add in people, lighting, material effects. I did cheat on this one. So like some of the trees that were right by it, they're kind of blobby from the drone, right? So I just put a Lumion tree on top of it and covered it up. So like this super detailed tree here, that's not actually from the drone. That's Lumion. Everything else in there is from the drone, but so Pix4D, SketchUp, Lumion.
I'm not real familiar with the individual Pix4D products. Every time I
Sure.
go to Pix4D, I see a ton of things and just trying
Yeah,
to-
that's
The whole crowd is back there. Totally talk to the Pix4D.
That-
Mike.
That's a great point. I always say Pix4D. So the one that you're doing the processing in is Mapper. And I just realized it's cut off, so you can't see it up there. But this is Mapper. So some of their other products that I use, Pix4D Survey is making some huge advancements for filtering vegetation out, so you can really manipulate the point cloud more. But you can do a lot of that in Mapper too. It's just surveys coming out with some more advanced tools. It's really geared towards surveyors who are using the same technology. The other one, so Pix40matic is interesting. It's basically made for huge projects, but where you don't need as much data. It'll process huge projects in a lot less time. They'll know better than me, but you can't get all the same outputs you can from Mapper. And then the final one, there's a really cool phone app called Pix40 Catch, C-A-T-C-H. And so it's for small areas. It won't work for huge areas, but you can use your phone, whether it's one of the new iPhones with LiDAR or if it just has camera in it. And you can basically go and it'll show you the photos as it's taking them. But you can basically do photogrammetry on an area like this, and you process it either online or with Mapper, and you can get the same stuff out. So I don't know if I have one up, but afterwards I can try to see if I have one to pull up. Like I did some, like I said, I do a lot of recreation work, a lot of trail work. I was evaluating trails in Lake Pueblo State Park and got some incredible models, like insanely detailed. You can see like nail heads on these wood features and stuff. And then we can model, we can take measurements, we can use that to explain to people what the issues are. And that's a free app. You just have to have something to process the data. Other questions? Let me see if I can see if there are questions on the online or not. Might have to stop sharing for a minute. Oh, we don't have chat.
That's where virtual should be able to unmute themselves.
Okay, yeah, so if anyone joining virtually, if you have a question, feel free to unmute. Otherwise, any other questions here? Well, thank you guys, and thank you Geotech for hosting this, and I'll put some cards and stickers and stuff out here. Thanks, guys.
With Geotech Environmental Equipment. I'm going to be talking about unmanned aircraft systems and how they're kind of being used in environmental applications. My background in this part of the industry started in 2016. Right before Part 107 rules were coming about, I wanted to begin operating unmanned aircraft systems that we were manufacturing and better understand kind of the rules through the FAA, and also really get engaged with local organizations to help kind of guide rules and regulations with the FAA as we were integrating unmanned aircraft systems. So I got my remote pilot certificate, Part 107, the month that it was released, in September 2017, I think it was, and have been renewed since then. I've got about 1,000 hours of flight time in my logbook, which is a lot of time flying multi-rotors. If you think 20 minutes of flight, I fly quite a bit. I fly for fun, fly professionally. I prefer to fly for fun, just more interesting to me. But I also like projects that are things we haven't actually done before. So we have a whole team, and we'll get inquiries from our clients to go conduct different types of work. And it's up to us to kind of identify if it's feasible or not. And some of these projects seem impossible at first, but as we begin to analyze and dig into it, it seems like unmanned aircraft are actually really a tool for those types of applications. I'll close this out and get it back going again. So we acquired Electron in 2015. Prior to that, we were doing contract manufacturing for Electron unmanned aircraft systems. They were based in Golden, Colorado, and the founder had started the company in 2009. His name was John Oakley. And he had manned flight experience as well as unmanned. He was building little hobby copters he would take out to the airfields with his buddies and brag about the type of technology and how fast they were going, and how long they were flying, and what kind of tricks they could do. So we started getting into real high-end kind of hobby. But he had this vision of making unmanned aircraft systems that would be used commercially. We could put them actually to work, right? And so he began to assess and analyze the market And what there was were military drones that were being utilized and been utilized since World War I. B-1s were flown remotely at that time. And then there was also hobby aircraft, which he was into at various levels of hobby, but there really wasn't anything that was commercialized. So he began designing some of his systems to carry different types of payloads and taking pictures and taking video and doing inspections and then putting thermal imaging cameras on them to see visible spectrums that we can't necessarily see due to heat variances. And so he began to grow his business, but early adopters were police, fire, and military. It really wasn't commercialized, so it took this different approach, right? Where police wanted to use it for situational awareness, which is really neat. So when we acquired Leptron, most of the customer base was either federal research or it was public safety agencies. And so with our acquisition, we really brought it into the commercial market to serve our existing customers who were already collecting data, usually below grade data, some surface data, and then these unmanned aircraft were also intended to collect data as well. So clients are collecting water samples, soil samples, air samples, but oftentimes the sites are being surveyed, right? Volumetric measurements are being taken within these offices as well. So this was a good add-on to our existing products. 20 years of experience, John Oakley, his vision. So I still look at this technology as being progressive. We're still really early on in the development stages and just our understanding of what the capabilities really are. And so anybody getting into the world of unmanned aircraft right now are still early adopters. It's going to change a lot. Rules and regulations are going to change a lot over time as well. So it's very progressive and it's increasing in popularity as well. So as it increases in popularity, we're seeing more advancements in technology, right? Demand is going to kind of create that technology. So in environmental applications, if we look at a phase 1 site assessment, for example, we're looking at the history of the site, right? We're also assessing kind of the surface of the property, right? Identifying certain aspects of the property that could be or pose contamination concerns that would go into our phase 2. Paint cans, drums, whatever it might be. And so the site visit, historically, we're taking images, and so I kind of have this evolutionary process of taking photos and cataloging your phase 1 site assessment, right? 35mm camera, cell phone works pretty well. But now we're implementing unmanned aircraft systems. And we're able to, when we operate these systems, we're able to cover the entire property at very high resolution. High enough resolution that we can identify whether or not it's a soda can, or a paint can, or if it's a Pepsi can, or even a Coca-Cola can, right? So very high resolution imagery over the entire site. It's also non-destructive. We're not trampling along the site, whether it might be snakes, this, that, the other. We're not trampling over certain species of plants, whatever. It's non-invasive of that property. But we're also collecting adjacent properties as well, which is kind of interesting information in our boundary. Just know, okay, where could the spread of this potential contamination go? And that boundary alignment outside of that property is pretty easy to collect. Obviously, assessing geological settings. And then the data that we're producing, we're able to understand topography pretty quickly and easily once we have that map put together. And so let me go back a little bit. We fly an aircraft and it's taking individual photos of an area. And then it loops around and it takes individual photos of the next line. So kind of like a lawnmower pattern. And we're using an overlap of 70% forward and back overlap and usually 70% side to side. Because we want to get as many pixels of any given section as we possibly can. 7 to 9 images of any given section is kind of our goal to make sure that we have really good coverage. And then we take those images and we stitch them all together. And when we stitch them together, it's an orthomosaic. It's a 2-dimensional kind of map or image of that project that we just flew. And the software that we're using is aligning every single one of those pictures. So if there's a corner of a curb, right? It's identifying from those 7 to 9 pictures that we got at that one particular area of where that curve is actually located. So it becomes a really clear picture and it's aligned really nicely. And every once in a while, the imagery doesn't align very well, so we have to do some tweaking. So it's almost like we have our Thanksgiving dinner out on the table, and we have our gravy dish, and we have our turkey, and we have our glass of wine or soda or whatever you have for beverages during Thanksgiving. And you take a picture of it, or multiple pictures, and then you print it, and then you want to lay that picture right on top of everything to make sure it aligns. But if it doesn't, you might have to tweak that picture to represent really truly what's on that table. So there's a lot of work in the post-processing to ensure that we get that orthomosaic. Once we have that orthomosaic, because we're taking imagery at an angle, we're picking up obliques, or the sides of objects. And so with that, we're able to create topography or 3D models of that property or that structure. It could be a vertical structure, it could be flat terrain. But we can create topographical maps and then identify our site boundaries and then also adjacent site boundaries. So phase 2, going into phase 2, we're beginning to go do below grade investigations. And I do get phone calls every once in a while saying, hey, I'd like to strap a baler to an aircraft and collect a well sample. Can I do that? You probably could, but it's probably not feasible, right? Is it that difficult for you to access that well? Drop a baler in there, collect your sample, purge your well, whatever you're doing. Unmanned aircraft just aren't great for bailing wells at this time, maybe someday. But ultimately, we can get subsurface data in 2 different ways. So magnetometers can help us identify anomalies in the soil, right? Maybe an old structure that was buried, or a tank, or it could be a pipeline, or an abandoned well, or whatever it might be. We can kind of identify those structures with an electromagnetic instrument hung from an aircraft. But we also use multispectral technology to identify vegetation stress. So from the visual eye, if you're looking at an area, everything may look green, or maybe it's in a dormant stage and everything's just gray. And it's hard to kind of identify whether or not there could be patches of different types of contamination on site. However, with a multispectral camera, we can actually identify stress from the chlorophyll or reflecting values of those leaves to see things that the naked eye can't actually see. So it's a 5-band camera that we use. It's going to do a very narrow band of red, very narrow specific band of green, blue, so we have our RGB, and then it's going to have red edge right on the edge of the spectrum, which we can't visually see, and then infrared. And then we have software and algorithms where we can manipulate that imagery and remove certain hues or add certain hues and different concentrations of each one of those layers to identify plant stress. And so with that, we can find invasive species, or we can see where there might be, we talked a lot about metals and hydrocarbons, or different types of contamination. So plants do react differently to different types of contamination. In terms of phase 3 environmental site assessment, but our remedial action in phase 3, excavation, volumetric surveys. So if there's a site where materials being removed, you can actually measure those volumes of material that's being removed pretty easily. We're also doing kind of a time lapse of those remedial actions. Asset management, so if there's clean earth or assets of soils or whatever else that's piled up, compost being sold, we can do volumetric measurements with that same data pretty quickly and easily to either bring in more material based on how quickly it's going through, or there's various reasons to maintain those assets. Vegetation restoration, post-closure, right, to see how actual plant health or vegetation is actually taken to the restoration of that area. Again, using the multispectral technology. And then we have found settling and a lot of erosion. So landfills, closed landfills, parts of the site that we've been able to identify from aircraft that we have some erosion concerns. That's bad for landfills, as well as other projects as well. So here's kind of just a dummied up model of, borehole logs, contamination sites, multispectral data, kind of showing plant health stress in those areas. It really pops out in the data collected we see. Yeah, it becomes pretty obvious where there's stress.
Any for the excavation volumetric survey? I mean, I know clients that they're just used to send a surveyor out there, spend the day, confirm what the trucks have already hauled away. I mean, just how accurate is it using this technology, or how do you sell it to a client that's used to boots on the ground?
That's a good question. So accuracy is going to be based on ground control, and the more ground control we add, the higher accuracy we're going to achieve. We find that accuracy is not always really required, like high accuracy. So for example, the aircraft, wish I had an example of without any ground control based on the volume, but it's not going to be highly accurate without ground control. So if you have permanent markers that are on site that can be used for ground control post-process, and as that digging hole is taking shape, they're going to get really accurate.
Okay, so benchmarks.
Sub-centimeter accuracy in terms of measurement and being able to create volumes. Yeah.
All right, especially for the Z-axis.
Benchmark, what do you mean?
Oh, I just mean that's your control point.
Yeah. And the more that we have around maybe that excavation area that we can continue to use every time we fly, then that we can pull some really high.
All right, so long as you plan for it.
Yep. Yep. And then without ground control, it's still pretty accurate, but it's what are we? We're probably, in terms of our accuracy, 3 feet horizontal and 5 feet vertical is about our span for accuracy. So that can really skew how
if you're measuring in
volume
cubic
is.
yards, yeah.
Exactly. Unless it's a huge area, right? Then the accuracy is probably acceptable. It's a smaller area, then you probably need to get that ground control to really tie in.
Okay.
Those volumes. Yeah. Good question.
What did you have?
As far as maximum size for these drones, I mean, is there kind of a max square mileage or area for if you're trying to measure an excavation? Is there an extent to how far the drone can measure? Really, I mean, is it 1 square mile, and after that, it's kind of out of range?
It's really based on the endurance of the aircraft. So how long can it fly and how fast is it flying? And then what altitude are we flying? If we're flying at a lower altitude, obviously, it's going to collect a much smaller area over a certain amount of flight time. Fly at a higher altitude, our ground sampling distance or visual ground sampling distance may not be as high. Let me try to just go to your question here. I'm sorry, I'm getting into the. One of our fixed wings can fly for about an hour and a half, which would give us about 400 acres. Right? And a multi-rotor is not very efficient, and so we're going to cover maybe 5 acres in a flight.
So that's the difference between the helicopter model and the airplane model.
Yeah.
Okay.
Natural lift, they're designed to fly, whereas
We'll go further.
multi-rotors are like just carrying a rock, and it just requires pure thrust. to keep
Are they
it
more
stable.
stable, or is that not a good comparison?
Stability, no.
I mean, with 4 rotors, they can get very stable if the wind is low.
Yeah, they're stable, but you can hover. So that's the biggest advantage to a multi-rotor over a fixed wing. You can stay in position. For mapping purposes, we always go on fixed wings. We don't fly mapping missions with multi-rotors anymore. It's just too much work, too many batteries, too many flights, too much data that we have to patch together. So we'll fly our fixed wings for bigger areas. If it's less than 5 acres, maybe we do just take our multi-rotor out. Yeah. So yeah, it's the right tool for the job, I guess, to kind of conclude on your question. Depending on the size and scope of the project, we manufacture a multi-rotor, 2 fixed wings, and a helicopter that we sell and also pilot. So we'll just figure out what payload you need, because helicopter carries heavier payloads than the fixed wings. So if we need LiDAR and And dual camera imagery, we're gonna take the helicopter out on site.
Do you manufacture those here?
We do.
Can we look at that process later? Or,
We have a cell back there which doesn't have really much to show, but I have a couple aircraft, I've got an aircraft under our booth that I can pull out, and I can grab another one as well.
are they composite or?
The multi-rotor is 3D printed for the most part, and then carbon fiber. And then we do have a kind of a Kevlar fiberglass fixed wing composite. Yeah, I'll definitely pull those out this afternoon. We might even do a flight demo if the weather cooperates.
I was gonna ask,
What kind of certifications do your pilots need to operate these?
That's a good question. So any of us can take any of our cool commercial aircraft, go fly them at the park and take imagery of trees and ourselves and whatever else, put them up on our Facebook page and show our friends, no big deal. But if we take one of those images and we sell it for anything, we put it on a postcard, or we decide to take a picture of our house and then later use it to sell our house, that's a commercial operation. And so you'd have to become certified through the FAA through a proctored exam. It's called the Part 107 exam. It's 60 questions, it's 2 hours. Upon passing, you have to have a 70% or better to pass. Then you can fly for commercial purposes. I'm doing good.
And do you always supply the pilots, or do people know how to do it? People who rent it?
So we have 7 pilots on staff right now. And so 1, they have to have the Part 107. 2, we have to stay current with our aircraft and operation. So if I haven't flown for over 30 days, I have to get checked through our chief pilot to then operate that aircraft. So there's some internal certifications, kind of safety things that we do. We haven't had a need to really hire anybody at this time. We just don't have the workload. We brought on 7 pilots early on because we're really coming into the market aggressively. And plus, we just all wanted to kind of understand the whole process. We all talk about it. And then we have the staff to be able to fill multiple projects as needed. And earlier on, we were doing a lot of demos and a lot of free data collects and a lot of free data deliveries, just proving to ourselves we could do it, but then also proving to the industry that we could do it as well. And so, we kind of came in strong, and we're still maintaining a pretty big pilot fleet. If we were to go out and fly now, I think there's probably 3 or 4 of our pilots that we would go to first.
And that's a service you would provide. You would rent either the equipment by itself or the equipment with the pilot.
Comes with the pilot.
Okay.
Yeah, absolutely. Absolutely. So our contract services will meet our clients wherever they are. So if you want to develop your own UAV program, we can help you through the entire process, right? From getting certified with a flight training course, we'll just go through this. So if we're going through contract services, there's some things that we're going to need. We're going to need to have a really defined scope. What are you trying to achieve? Because that scope can't move after we delivered our deliverable. So we're really going to work through project scope and then feasibility. Does it make sense? We're going to tie a baler to an aircraft and go collect all our samples as well? Probably not. Right? But if you want to map a project or a construction project or phase 1 site assessment, absolutely, let's go after it.
You could probably collect lake samples, right? Surface water?
We could, and there are companies that do it, but there's some challenges with dangling payloads with autonomous systems.
Okay.
So manned aircraft can kind of feel the sway and maneuver with it, whereas an autopilot system isn't predicting that. So it can be done, but it's risky.
We do have one client right now that uses a water quality sign, and they use it to profile reservoir. But the challenge being is the longer the cable, the bigger the pendulum. And we talked about it on the phone, so the longer the cable, the bigger the pendulum. So they have to be very careful with wind speed, direction, and how fast they move, because the weight of that piece of equipment, the drone doesn't natively understand that, right? So.
It doesn't, the pilot can't feel it either.
They don't have
Those helicopter pilots that actually fly dangle payloads, pretty amazing. Those are pilots for sure. It's risky stuff. I've even seen a pilot that was removing trees for forestry, and he'd fly in, and then release, right? And the tree would fly into this pile of trees that he's collected, and then he would just take off again. Like, it was rad. It was so cool. So that's where the technology is going to continue to get better, right? Because dingo payloads, there is definitely a need for that kind of stuff. So we've worked with some of our autopilot systems to kind of predict and try to handle those kind of payloads safely. And it's coming together. So contract services, hire Geotech, we want to know what kind of data that you're looking at collecting. We're going to ask about accuracy, like what specifically you want for accuracy. We'll meet it. If you just say the best accuracy that we can achieve, open up your pocketbook. Because it's, we're going to spend a lot of time out there really getting everything fine-tuned. Timeline, frequency, etc. But if you decide to launch your own program, we have a full 5-day training class, which includes 20 hours of ground school training, which will prepare you for the Part 107 exam. And then we also have a 20 hours during the same week, practical flight training. Start with real basics, ergonomics. You're going to be out there for 20, 30 minutes. We want to make sure that you don't get fatigued as you're doing your mission, right? So how do you hold your controller? Just ergonomics, taking off, landing, various types of maneuvers. And by the end of the week, we're doing really more advanced maneuvers manually, but also a lot of autonomous flight mission planning. So it's really progressive throughout the week. At the end of the class, everybody takes the Part 107 exam. So for all the 600 students that come through our course, everybody's passed so far. So we must be doing something right. At first, everybody was getting about 73, 74 percentile. We're like, oh, we're going to make this better. So we improved the class, and everybody's averaging about 85 to 90. So the scores are getting better. We can help with hardware selection. So we manufacture our own systems, but we also distribute some of the other major brands as well. So if our systems don't make sense for you or your budget, we can kind of help you understand what hardware might be best for your applications. What else about hardware? The flight training class is a great way to kind of get your hands on the hardware. We've got a lot of stuff to fly, so you really can kind of identify what you like, what you dislike about systems. The screen is too small, can't see it in the sun, the flight time's not enough, right? So when you do go out to the market to pick up a new aircraft, at least you have a better idea as to really in a real world situation what might work best for you. And software selection. So if you're doing any sort of post-processing, we're not married to any software company, but we have worked with a lot of them and have good relationships with a lot of the major software companies, and some are better for other things than others. So if you're doing tower inspections, kind of great software for that. If you're just doing general mapping, great software for that. If you're looking for something that's completely autonomous and just does everything for you, you got something for that. If you want to be able to manipulate and tweak that software and get into the nuts and bolts of it, there's some recommendations there as well. So kind of fitting a whole program together for you. And then shadowing. The data collection, mapping, and post-processing is a whole class in itself. And we really haven't found a great way to do this other than teaching or at least shadowing with our clients. So if you want to learn how to do this, you have a project, hire us, stand next to us throughout the entire process, because we have a very systematic approach to what we do. Learn it, see if it's something that's going to work for you. All right. Maybe we'll have to do 2 or 3 different projects just so you can see the whole system flow, because it took us years to figure it out to actually get good data. And unfortunately, there's anybody who has a drone and can afford software, thinks that they're mappers and they can produce high quality information and data, is destroying this industry, right? They're going after waste management, Republic, environmental consulting firms, and they're producing really bad results, which is creating a lot of doubt in these industries. I don't think unmanned aircraft systems really are what they're cut out to be. But the reality is they are. You just have to have a qualified team out for it. I'm not going to talk to Jason, the environmental scientist, about my taxes and having to do my taxes. I'm going to go to a tax consultant or an accountant. So ultimately, we've kind of gone through that trial and error. and we figured it out over the years.
And Andrew, I'd also add that, be careful of who you contract. If you go out and contract, people, make sure they are certified. My wife works in the real estate industry. We've seen an explosion of drones and UAS being used for taking pictures of houses. You wouldn't believe how many of these people are not certified.
Yeah.
And they're popping them up where they shouldn't be. Next thing you know, people are showing up, trying to figure out what popped up in the air out there. Questions get asked. You got to have answers, right? So we've had a fire department come through here a couple of years ago. They had put a drone up in the air. They weren't the one detected. Some private owner of the drone was up higher than them, was detected by Centennial Airport on this highway fire. And the local fire departments had this lower. They got shut down. So even on, that level, a major fire department here in Denver, they got shut down from flying those because they didn't have the license. And it wasn't even their drone that was detected. It was somebody else's, as a private owner. And even that person was so close to the airport in the area that was a danger.
It's okay to ask for credentials.
Yeah, it's okay.
Remote pilot who you're wanting to contract services for. Oh, I got my wallet in my office, but I should be able to open up my wallet and produce my remote pilot certificate. Right. It's okay to ask for that stuff. Pilots are expected to ask for that kind of stuff. That's a good point. And insurance as well. So we insure our aircraft and our pilots. So in case anything happens on your site, we're covered because there is risk involved with operating unmanned systems for sure. Good. Any pilots in the room? I should ask this early on. Like, who's flying aircraft?
104.
What's that?
104.
Okay. How many hours do you have logged?
50 maybe?
Okay.
Well, how much?
Yeah, it's kind of like a pilot's odometer, right? You ask how many hours they logged, it shows kind of their experience. So if you're hiring somebody else, and maybe another question to ask, how many hours do you have logged? Like, how much experience do you really have operating these systems? Brand new? Well, low risk site, let's give you a shot. And maybe you're looking for somebody more qualified just because of the high profile or importance of the project. Sure. Anybody want to fly unmanned aircraft? Like, even considering it? Yeah, for hobby purposes, who wants to fly for hobby?
I do it for hobby now.
Do you?
I've been flying for decades.
What do you fly, fixed wing?
I fly kind of like 4.5 meter electric sailplanes with folding props
Okay.
for aerodynamics.
You're a real pilot. You don't have autonomous operations in your systems, man. You gotta fly yours.
A little bit. Yeah. I mean, it climbs like 4,000 feet a minute. We can't get that high legally, but.
What's our cap?
400 feet.
For hobby and commercial? 400 feet? Yeah. And then manned aircraft is at 700 feet. So there's a buffer there, so we don't collide. Yeah. So that's part of that Part 107 exam is understanding airspace. Where can you fly, where can you not fly? It's very busy. US airspace is crazy busy. So we have to know where to operate. Because the hobby aircraft are being affected big time in terms of like rules, regulations, registrations. And then drone operators wanting to fly at your parks and you guys don't love it. And there's kind of some conflicts there. It's like snowboarders and skiers kind of trying to get together early on.
There are many of those snowboarders. That's good.
Does the monitor, when you're looking at it, does it give you your altitude? I'm sure you're saying how high you're.
It should. Hopefully the pilot has all the flight data information.